Alright, so we are going to review for your Unit 5 test on probability, which we'll be having tomorrow. Let's start with going over the review sheet. So for number 1, you're writing out the sample space. So whenever you're writing the sample space, it's always the S, and it's a set of numbers, or items. So in this case, I have the set of 1, 2, 3, 4. Since period 5 is lunch, we don't include that, and then 6, 7, and 8. For a pick of an administrator at Northwest High School, you basically have 5 different options: Dempsey, Robertson, Kniper, Posture, and Mr. Britton. Okay, so again, make sure you write out the sample space, and again, sample space is always notated with the letter S. Okay, so for number 2, what are the following probabilities? For this first one, probability rolling an odd number on a toss of 2 dice. And again, this would be the sum of the 2, and it's kind of unclear here, but this would be the sum of the 2 dice. So whenever you do this, you want to probably go ahead and look at either a tree diagram or a table, or you can actually write out the different ways that you can get this odd number. For this, it actually turns out that it's half of the numbers are going to be odd on the toss of 2 dice, and you can either write this out or you can think about it logically, but however you do it, in this case it's going to be half of them. So if you want to see it, you could do it like this, and then 1, 2, 3, 4, 5, 6, and then think that for this one, 1 plus 1 is even. This is going to be odd, even, odd, even, odd. Okay, so you can see that for each of these, it's going to be half of them. Whenever you add 2, it's going to be the same thing. So 2 plus 1, odd, even, odd, even, odd, even. So you could see, you could get the pattern. You really don't even have to do the 3, 4, 5, or 6. So you see that 18 out of the 36 are going to be odd. The probability of having a girl and a boy out of 2 children. Okay, so again, you want to think about a tree diagram, the reason why there are 4 outcomes. So on the first one, you can have girl, boy, and then the second can be a girl or a boy, and then the same thing, you can have a girl or a boy. So which of these outcomes actually give you having a girl and a boy? So this is girl, girl, not that one. Girl, boy, boy, girl, boy, boy. So you can see that there are 2 options out of 4. The probability of selecting a face card from a deck of cards. So for this one, you do have to make sure that you know a deck of cards. So there are 4 suits to a deck of cards, and there are 3 face cards for each suit. So since there are 3 face cards and 4 suits, that means a total of 12 out of 52 cards, therefore 3/13 or 0.23. Next one, probability of a face card given you get a face card on 2 successive picks out of a card without replacement, meaning you pick one and then you pick another one. Okay? So remember this given, you have to know your formula. Okay? So whenever you have that the given, you know it's the probability of both, so face card and intersection face card, divided by the probability of getting a face card. Okay, so what's your probability of a face card and a face card? And again, these are dependent events, so my first is going to depend on what my outcome of my second. So if I get a face card first, that's going to be 12 out of 52. Well, if I already have a face card, then I'm only going to have 11 left out of 51 cards. Okay, so that's why you see the 12 out of 52 times 11 out of 51. Okay, now then, what's my probability of just getting a face card? My probability of just getting a face card is 12 out of 52. This notation should be seen, okay? That's a very important notation for you to show. Okay, so then you want to simplify. The 12 out of 52s will cancel. You're left with 11 out of 51, which is 0.22. So the probability of a black or an ace when you pick one card. So the probability of picking a black, there's half of them are, so 26 out of 52. Plus the probability of picking an ace, there's 4 out of 52. Now for this one, these are joint or disjoint. So in other words, if these are my black cards, can I have a possibility of having ace with aces in those blacks? Well, yes, I can have aces in there. I have black aces, and I have two of them. I have two black aces, so that's why I have to subtract out two of those black aces, because I've accounted for them in my set of blacks and in my set of aces. So you simplify 28 out of 52, which is 0.54. And then finally, F, my probability of a king and the complement of that. So I have to first identify 1 minus and then my probability of getting a king. There's 4 of them. Subtract and simplify, you get 0.92. Moving on, number 3, the probability that a company will win a contract is 0.45. What is the probability of the complement? Describe the complement in words. Okay, so the complement really, remember, is 1 minus whatever the probability of that event is. So there's 1 minus the 0.45, which is 0.55, and this is the probability, basically, that they do not win the contract. For number 4, suppose that the probability that Jane will be president is 0.4, and the probability that Jack will be president is 0.3. There can only be one president, and there are 3 candidates running: Jane, Jack, and Jenny. What is the probability that Jenny will win? Okay, so you already know Jane and Jack's probability. So therefore, you have to take and subtract 1 minus those 2, and you'll find that with Jenny, there is another 30% chance of winning, or 0.3 chance of winning. So Jane has the highest chance of winning. 1 minus 0.7, there's your 0.3. Okay? What is the probability that Jack or Jenny will win? There's my or, so therefore I'm going to add. Remember the ors, you add. Okay? Whether they're disjoint or not is going to determine if you have to subtract anything out. So probability that Jack, probability of Jenny, add them together, you get 0.6. What is the probability of Jack and Jane will win? Well, in this case, can both Jack and Jane win? Answer is no. In this case, I cannot have both of them win, so I should not use multiplication in this case, and therefore my probability is 0. Alright. For number 5, suppose that Carrie will pass English is 0.92 and the probability she will pass math is 0.78. Are these disjoint events, and how do you know? Okay, so you have to ask yourself, for disjoint, is it possible for Carrie to pass both English and math? And the answer is yes, it is possible for her to pass both English and math. So therefore, no, they are not disjoint. And for this one, you're going to look and at the basically the intersection, should be upside down U, of what's the probability of passing English and passing math. So 0.92, hold on for a second. Well, this is another way you could do it, I suppose. So if you add them both together, you'll find that you have a probability that is greater than 1, which is 1.7. So if that's the case, then you know that there's going to be an overlap. You could also calculate the probability of the intersection of the two in order to find out what exactly there is in that intersection. For letter B, what is the probability of Carrie passing both English and math if they are independent events? And again, it is important for you to know that they are independent events because that is the only way that you can multiply the two probabilities, and therefore you get 0.72 when you do that because of the and. And then what is the probability of passing English or math? And again, add together and subtract out the overlap. You just found the overlap in the previous problem right here, and then you get 0.90. Okay, for number 6, what is the probability of tossing heads on 12 successive tosses of a coin? So that means you flip one, you flip the next, you flip the next, you flip the next, you flip the next. That means you want heads, heads, heads. So basically the probability of heads and heads and heads, etc. So basically you're going to multiply all of those probabilities together, 1/2 times 1/2, which is basically 1/2 to the 12th power. For number 7, if 90% of people have a home phone and 50% have both a cell phone and a home phone, what is the probability that a household chosen has a cell phone given they have a home phone? So here's where that given comes in, okay? That's the key word you need to look for. The given is represented by that vertical bar that we talked about, okay? So first off, you have to look at the probability of having a home phone is 0.9. The probability of having a cell and home is 0.5. So therefore, you are looking for the probability that they have a cell phone given they have a home phone. So that is cell phone given they have a home phone. So again, you're going to use your formula, cell and home divided by just home, and you simplify 0.5 divided by 0.9, which is 0.56. Okay, for number 8, tables. The first thing you're going to want to do is to get all of your totals for your table. So 350 plus 35 this way is going to be 385. 1500 and 150 is going to be 1650. Then again, you add this way and this way. And then you want to total your entire table, which is 2035. Okay, so now you can answer your questions on probability. What is the probability that someone in this group works out? So just in general works out is 1850 out of your sample size of 2035. What is the probability that a student works out given he or she is a smoker? So workout given smoker. So the probability of workout and smoker is 350 divided by the probability of just a smoker, and a smoker's there's 385, so 350 divided by 385, because the denominators will cancel, you get 0.91. Then you want to do the opposite, smoker given workout. So the probability of smoker and workout, we already said, was 350. Probability that somebody works out is 1850. Simplify, you get 0.19. For proof of independence, okay, you need to show that this is true, and therefore when you take the workout given smoker and the probability that they work out, they end up being the same. So they are independent. What is the probability of selecting a student that smokes and works out? So smokes and works out, 350 out of 2035. And then smoker or workout, so add them both together and subtract out the overlap of 350, and you get 0.93. I'm just going to go ahead and stop this video and continue number 9 in the next video.